The next part of our configuration will involve setting up server load balancing. So, what is server load balancing? Well, this is the capability where client requests can be distributed evenly among a group of servers, shared servers. And this has many advantages such as improved performance, and it provides great reliability. So if one server in a pool should fail, client requests would be redirected to a different server. So this picture here kind of demonstrates what server load balancing really is. That a particular request would hit the big IP first. The big IP will determine, well, which of these servers in the pool to send the client request to, and it will send it to that server for processing. Now, to configure load balancing on a big IP appliance, it's important to understand the components that are involved and how they should be configured. And these main components involved are nodes, pool members, a pool, and a virtual server. Let's talk about each of these one by one. Each server would be considered as a node, and a node is a server that isn't attached to a specific pool. It is focused on the server itself. So instead, it can apply to all pools it may be associated with. So it is based on the number of connections to that IP address. So for example, a single server could exist in a web server pool providing web client requests. And that same server may exist in another pool like a FTP server pool providing FTP client requests. That server can be represented as a node, which can be used for load balancing decisions. Here's another example. So we may have a server that has a total of 50 web connections and 25 FTP connections coming in from different pools. Well, that means that there's a total of 75 connections to that node. So we may not want to overwhelm that server with many requests. This is something that we will strongly consider and set up in our environment when it comes to the different load balancing methods. A pool member is simply a node that is added to a pool. There, it will be based on the IP address and the service port it is configured for. So for example, a server can be added to a server pool for HTTP requests only. The next component is a pool or a server pool, and that is a group of pool members that will host the same type of content like a web server farm or an FTP farm perhaps. The configuration of a pool involves a few other components on its own. It contains adding the nodes or the servers, which would then be represented as pool members, and specifying the service port for each server that is added to the pool like HTTP or FTP, for example. You can also define a health monitor to the server pool, and you can define the load balancing method for how traffic will be distributed among the group of available servers. Another component is the virtual server, which will listen and manage traffic for the associated server pool. This is what clients on the outside would connect to directly. It is the virtual server that will do a network translation to a member within the server pool. Now the source IP, the IP of the client, will not be translated, only the destination, which is basically the member itself. This also contains many configuration parts to set up a virtual server. It involves adding a virtual IP address, sometimes called a VIP. This would be an IP address that would be mapped to some DNS name that the client would connect to. Plus, with that virtual address, you need to specify the service port, which will typically be similar to what you set up in the server pool like port 80. Another component that is important is associating the appropriate server pool to the virtual server. And there's other components that involve enabling SSL processing and enabling persistence, which is what we will do in this video series. Another component that I want to quickly discuss is the use of the default gateway of the servers in a pool. So it's important that for each server in a configured pool, that its default gateway is pointing to the big IP itself. Otherwise, you may encounter asymmetric routing issues where the return traffic may go through a different router and could break the connection of the client. So for example, If we have our big IP, and if this is the IP configured on the LAN-facing interface of this device, then all the servers in the pool, their default gateway must point to that IP address. And this picture represents a logical view of what we'll be setting up for server load balancing in our environment. So we will be configuring a web server pool that will contain 4 web servers based on our design diagram and how they're connected physically. Now that pool will be added to a virtual server using the virtual address of 10.254.1.10 mapped to port 80, which is the HTTP application. Now for testing, we'll be using our computer right up here that is connected externally to this web server farm, and we will use this virtual address for connecting. Now that virtual address will be mapped to a DNS entry called wsroutehub.local.